Okay, so I'm going full screen. I hope everybody can see my screen all right. If not, feel free to unmute yourself and then just let me know because I won't be able to see your message or any emoji over there. Hope, yeah, let me know if you cannot see my screen. So first of all, I like to introduce the core mentorship team behind the YSIS, the second cohort project. Uh, and oh, by the way, tonight, so this is what will be covered. So what YSIS is and why it exists, and what our first cohort built and won, and what's our second cohort project, why it starts with you, and what we're looking for in the team members. And number five will be how to apply, and the last one will be your questions. So cohort members, sorry, the mentorship team will have three people for this group. The first one is me. My name is Chloe. I'm sorry. My name is Chloe. I'm the founder and director of YSIS, and I'm also actively involved in guiding and assisting the cohort projects. My background is STEM education and entrepreneurship. I've been doing this for the past 13 years. I hold a master's degree in STEM curriculum planning and practice from a specialized program developed in collaboration with Adams State University and the NASA Endeavor STEM program. I'm also currently completing my second master's degree in education leadership, concentrating K-12 pathway at a Harvard Graduate School of Education. Now, the lead mentorship is Dr. Lim. So Dr. Lim has been on board for the past cohort, which is our first cohort project, and who's also here today. Dr. Lim holds a PhD in mechanical engineering from University of British Columbia, and he's currently a professor of mechanical engineer at Seattle Pacific University, where he teaches senior engineering classes and also capstone projects for undergrads engineering students. Dr. Lim served as a lead mentor and a facilitator for the YSS cohort projects and will continue to support and mentoring students in our second cohort. I would like to also introduce the specialty cohort mentor, Dr. Gurley, who's not here today, but would like me to say hi to everyone. So she is a specialty mentor, bringing in the rich background knowledge and experience in environmental science because our second cohort project will be an environmental issue. Dr. Goulet holds a PhD in environmental science from University of Victoria and is currently a sessional instructor in the Department of Biology at the University of Victoria. We have Dr. Goulet join us for this cohort, and so she will provide mentorship and guidance in this area, which involve biology and environmental science and sustainability, supporting students as they explore real-world environmental challenges through the projects. She will also be part of the feedback group, giving the feedback on the solutions the students develop during the engineering design process. So let's move on to the next slide. So what is YSIS? I think I'm gonna start from the simplest way to describe what YSIS is. YSIS was founded 2 years ago with the goal of creating a space for students who are not only passionate about STEM, but also interested in using STEM to make meaningful changes in our community and the society. This is a place where teenagers work on the real problem that matters to them, guided and supported by the professional mentors have their work in the real world, and build solutions to create genuine changes in the world. So this is not just a class. It's not just a competition. This is also not just a club. It's the team working towards a real goal, and everything we do and learn grows from that idea. Why do we exist? So why do we exist? Because the world is changing. and the way we think about learning needs to change with it. Today, the knowledge and technology are more accessible than ever before. You want to learn quantum physics, you go to the AI, you get a basic concept of it. Because of that, education can no longer be the only about memorizing the information and express this information. The future will belong to people who can think creatively, adapt continuously, collaborate with others, and turn the ideas into meaningful action. So you got to know why you're doing things and what do you need to do these things. And honestly, all of you being here tonight because of your passion for science, technology, engineering, or math, that is a very good start. The real question is, how do we grow from that passion? And how do we use it to contribute meaningfully to this world around us? So at YSIS, we believe young students' ideas are valuable when students are given the right tools, mentorship, and opportunity to work on the real world challenge, you will begin to see what you are capable of creating. So, through that process, students will not only have the skill and knowledge, but also confidence, purpose, and the belief that you can make meaningful change to this world. So, how does a cohort work? So, let me walk you through how the cohort works in practice. Each cohort work together on one shared project. So for cohort two, we are going to have four members. So possibility of having two different prototype is there. So two members working on one prototype or four members working on one prototype. We are flexible on that. For the first cohort, we had two members working on one prototype. So each cohort works together on one shared project, so your problem is going to be the same. So the project is going to be the same, which is dividing into three phases. If students choose to continue through all three phases, the whole project may span up to 1 year. However, the timeline can vary depending on the project itself and the goal of the group. At the end of each phase, we will have a checking point where students can reflect on their experience and decide whether they would like to continue to the next phase of the project. So once the students commit to one phase, we do ask for full commitment through the completion of the phase, usually 2 to 3 months or 2 to 4 months, as each stage is designed around achieving a specific milestone in the overall project journey. So phase one will be on the building the foundation, skill building, real project application together. So basically, you understand the problem, identify the problem, and having the idea of the prototype, and turn the idea to pre-prototype. So that's something happening in phase one. And phase two is to building the actual prototype and testing it. And in this phase, we're already able to enter your project into different competitions or different grant, which later I will be talking about that later. And the phase three will be the final, we call it final stretch, which will take the project to a different level, which later Dr. Lim will elaborate more on that phase. So the weekly rhythm is very straightforward, and the time commitment is also very straightforward. Each week, the team meets for 3 hour session facilitated by Dr. Lim. In the middle of the week, there are also team checking in, which will be led by your cohort leader, who is a student member within the group. So with us, we wanted the leadership to be part of the learning experience from day one. Okay, so Dr. Lim, would you like to talk a little bit about phase three of the project?
Yes, of course.
Okay.
For phase three, because in engineering and science, the presenting what we've learned, what we've achieved is really important things. So that's why we think phase three are is necessary steps. So, for example, uh, through the phase one and phase two, you guys learned some basic fundamental idea and skill, and you follow the engineering design procedure. After learning all of things, you can present what you've learned, especially by using innovation pitch or research papers. Especially for research paper, you guys will be able to join actual research based on what you've learned. So, for example, you will obtain some kind of fundamentals of robotics and mechatronics, or you can learn sensor integrations or real-time data acquisitions, and also you will learn how to design feedback control system. And by doing experimental tests and data analysis, you will get some proper and very advanced research result. Using those kind of research results, you can join how to write and learn how to write technical papers.
Great. Thank you so much, Dr. Lim.
Thank
Um, I can give a little bit of feedback on the innovation pitch. So currently, Canada and also whole North America start developing the innovation ideas, starting from university and penetrated through the high school students even. So a lot of platforms and also grant are given in this area, which I think that's actually a very great energy to cultivate this creativity and thinking outside the box to start from young age. So there will be a lot of opportunities in terms of innovation pitch and getting the investments and also that kind of opportunity down the road when you reach that phase. Okay, I'm gonna move on to the next slide. Thank you, Dr. Lim again. So here are the pillars of our organization and also in each project. Everything we do here is built around those four pillars, and these are not just ideas on the slide. They do shape how we approach every project and every session, and we want our member to be on the same page with us. So first of all, we believe failure is a part of a growth. When something doesn't work, we learn from it and improve. And second, we encourage students to stay open-minded and curious, but because the real learning happens when you're willing to explore beyond
不好意
what
思，
you
不好意思，
already
这么
know.
快？老师要去伊森家
Um,
上课。I don't know another
sorry,
student.
sorry, can you mute yourself, please?
Okay.
Thank you.
Using this. Yeah, yesterday I
Okay,
talked to you.
yeah, can you,
You
yeah, if
remember
you
the
can
science
mute
fire?
you can mute
Fair.
yourself would be great.
You want later? You want to listen? 哎，你送老师的，别走了。老师走了吗？
Shirley, can you mute yourself, please?
Oh, sorry, so sorry.
Yeah, it's okay. So we don't accidentally hear any secrets there. Um, and third, we value the creativity, innovation, and the courage to bring the meaningful ideas to life. And lastly, recognition. I think that's a big part. I know how hard it is to walking down the path of unknown. So any of recognition is definitely the motivation, but then they are not the destination. Awards, they are meaningful, but purpose and impact always comes first. So with our group of students, they win a award, but we always remind them like you gotta go back to initially when you're doing your research, when you're doing the interview, you gotta go back to that. Why you doing that? Because only reflect on your intention that will allow you to walk far in this innovation project. So let me move on to the next page. So what do you actually get? You spend 3 hours a week. That's a long hours, and then at least 3 months in a project. That's also a very not short period. So what are you gonna get? So this is a slide we're gonna tell you. So students will develop both technical skills and a real-world experience. This includes areas such as engineering design process, which something that I truly resonates. Engineering design process, I apply this process in the decision making and also solve the business problems. I found out they're really rational and adaptable, and they're definitely a very good transdisciplinary skill to have. Um, They're coding, LLM, and application, research, communication, teamwork, which is very important skill for young students to start building at this age, and a subject-specific knowledge connected to the project. And most importantly, students apply these skills in a meaningful way. You build a solution to a real problem, working alongside of a professional mentor, participating in science competition. So you meet the peers. You're going to meet the peers and the students that share the same passion with you, challenging on each other's innovation and creativity, and experiencing elements of research and entrepreneurship firsthand. But for me, I'm from education background. So I think beyond the technical side, the biggest growth often happens in the mindsets of young students. You build a resilience because you're gonna fail a lot, and you're gonna build a confidence because you conquer your fear, and then build your critical thinking, adaptability, and the courage to publicly share and defend your ideas. And with that, I would like to introduce someone who can speak about this experience far better than I can. So Blake is currently a grade 9 student who has been the part of a YSS project since last summer. So they've been working on this project for 1 year. So today he will share more about his experience and also project he has been working on together with his cohort members. So Blake, are you ready to take over?
Yeah.
Okay, thank you. Take it over.
Okay, so hi everyone. For the past few months, I've been working on an assisted robotic arm. Essentially, what it is, a non-invasive and essentially cost-effective robotic arm prototype designed to provide mechanical assistance. We built it on Arduino architecture, and we use high torque servo motors to control wearable load cell interface. So, where did the idea come from? So, essentially, the idea was we got it from identifying and analyzing a gap in the assistive technology market. So when we did some research, most robotic prosthetics are either prohibitively expensive or requires invasive procedures. So what we wanted to test was if industrial grade sensors like a load cell or amplifier could be um, repurposed to create something functional or like a smooth interface at like a fraction of the normal cost. So what does a robotic arm do? So our device detects the user's physical input and provides a corresponding like force to aid the movement. It basically transfers the data into a fluid motor response, ensuring the arm moves naturally. So our goal for these past few weeks is what's the word? Autonomy. I'm designing this for individuals who need physical support and lack the resources for high-end medical robots. So when we provide a responsive, affordable tool, we basically bridge the gap between the user's intentions and the physical capabilities. So we have like throughout this journey, we learned so many things. So one of the things we learned was how to coordinate C++ and um like technological components. So we learned circuits and how to use code logic to function the overall robot. We also learned mechanical precision. So this project taught me to understand 3D modeling in SolidWorks to like account for factors such as stability and how robust it is. And furthermore, we also touched on iterative engineering. We learned the importance of like engineering drawings and then the overall process of making it.
Great, thank you.
So yeah,
Do you mind if I ask you a question, Blake?
yeah, sure.
If you could go back and say one thing to yourself at the very first day of this project, what would it be?
I would probably tell myself how far I would have got because we've won so many awards and we've been to a lot of regional competitions. I never thought I would get this far, so I just tell my past self to like keep pursuing this, what I'm interested in, what I enjoy doing, and I want to eventually reach somewhere.
Great, thank you so much. Thank you very much. Thank you, Blake.
No worries.
So Blake and Ethan, they're the two cohort members. So for this project, they join in this cohort. with no coding experience, no engineering exposure, no knowledge of a sensor Arduino board and programming, just a problem they care about, and with the help to figure it out. I think Blake missed out one thing, how they found this problem. It was actually right at the beginning, we decided to use accessibility as the big idea. So they are the one interview someone from Richmond Center for Disability. Through the conversation, the person was mentioning because he didn't have a very obvious disability, so he mentioned that but he does carry the minor injury on the legs and joints, which doesn't allow him to travel aboard. So he was mentioning how expensive those assistant device are, and if he could just rent it to have a very nice trip. I think that was a clicking point for these two boys, and that's how they come down to decide to design affordable version of this assistant device. So thank you. So this is some photos just to show. I took it when they're making their first projects. This is engineering design drawing, which with the details of the parts and also the measurement. And this is when they just started working on the pre-prototype at that time. I think it was last year. This is a very sorry.
It's customizable.
Let me give you
Robot
uh,
control things in your household. Like it's a
so before I play this video, I wanted to let you know why I'm showing you this video, because this is a very important part of the project and the process. We don't tell them what to do. But then after we define the problem we want to solve, we wanted to hear them what solution they have. MIT currently, I think not currently, last year they start promoting this, Google Lab promoting this moonshot idea, which means you think wildly and then we make pieces together. We connect the pieces together. So this is how they share how they share their solution proposal in front of each one, in front of Dr. Lim and in front of the members. And then something that's really interesting is they do question each other's solution, and then they do challenge on each other's solution, which I think it was really inspiring to see and really fun process. So I'm going to show you these 3 short clip.
the buttons on the remote. And then you can use the buttons. It's customizable, by the way. So it's like a robot, but the buttons like control things in your household. So like different lights or like doors where like
These are really customizable. Yeah, on your phone.
there's on your
Yeah,
phone.
I just like this stuff. This one, yeah, but that's like compromise.
Something. Anyway, and then there's yep, and then there's a battery on the back, and then that's how you power it. Okay.
How does it connect to all the? Yeah, is it more cost efficient than that one? Why should we use this instead of the other things?
It's more cost efficient. And
How does it work cost efficient?
And then also, but it can't mishear you.
Oh, sorry.
Yeah.
This way it stays that way in the folder here.
Oh,
It's the AI system is that. It's so replaced. Oh,
backwards.
so link and joint system. Yes. It's actually machine. Yes. Yes. So. Yes, yeah. They say something and oh no.
Oh,
So there's like an AI system in his head. No, not in his head, in this part. Not in his head. Okay.
So I didn't capture the full, I didn't share because it'd be too long if I capture the full presentation. But this is the video.
How you feel?
Pick up stuff now.
You can pick up stuff faster.
That's online.
So this is a pre-prototype stage where they built this assistive system using the cupboard attached to the hands and testing out how helpful and how powerful using this type of motor. So that's the video. And I think this is a really updated clip, just happened right now. Currently, they're working on the accuracy of the weight detection. I think that's a sensor. Blake explained better than I can. So, and this is one of the award that they won. It's Riddle Hall Ingenious Plus. This is actually very I wouldn't say it's prestigious, but then this foundation, their award carried a lot of weight. For this award, they won $1,000 grant, make it to the regional. There are total about 30 projects made it to regional. And unfortunately, this year they couldn't make it to the national. I think we can try next year for sure. I think for me, what's particularly meaningful for this process when they're getting this reward ceremony at the governor's house, it's they got to make friends, connections, and they got to meet with many students like-minded and share the same passion. From there, I think that friendship, that relationship, that challenge they build on into each other, that's something that's truly valuable in this process. Okay. So overall, across I think across the whole year, this project won a Science Fair Bronze Prize in the regional, and the Science Fair Foundation, I think it's called Julia grant. They won a $200 grant, and the Rideau Hall Foundation, they won a $1,000 grant, which they actually already been putting on their device to improve certain part of the device to make it better. So let's talk about the second cohort. Why the environmental problems? Why now? Community here in Vancouver are already experiencing the real effect of environmental change, worsening air quality, increased severe wildfire season, and which caused the evacuation in nearby communities, extreme heat events, and shifting climate pattern that affect everyday life. And many other parts of the world have been facing this challenge for years before we began experiencing it here. So these are not abstract future problems. They are real issues happening right now. So why does this need young minds? Most environmental solutions today are designed by adults. For adults, often using the same way of thinking that carries limitation and distraction of existing systems. Young students bring something different. You haven't yet been told what's impossible, and you ask questions that experts may have stopped asking. And perhaps most importantly, your generation will live with the consequence of these environmental challenges the longest. Your motivation is personal, not just professional. So from the technical perspective, the intersection of robotics, sensor, coding, AI, and environmental science, it's still rapidly developing field. There's no fixed playbook yet, which means creativity and curiosity matter just as much as the experience. So with the right mentorship, we believe, tools, determination, a small team of motivated students can genuinely create ideas and solutions that have never been explored before. So your choice, student choice is always at the center. When the project begins, students are not simply handed in a topic. The topic could relate to air quality, water system, urban heat, and so on. So you're gonna decide, you're gonna choose among your team members what environmental issue you genuinely care about. This could include all these area and then you feel you can resonate with. From there, your prototype and project direction, it will be grow from your ideas, your interests, and your ideas. So what the projects will involve, subject-wise. So project sits at the intersection of three disciplines, as I mentioned, environmental science, robotic engineering design, and programming and coding. Um, these are areas not taught separately. Instead, the students learn to connect them together through one integrated and purposeful process as they research problems, design solutions, and building prototypes, and test their ideas in a real-world context. So this is the first phase. We have three phases in each project. So the first phase, this is what it look like. First, students will work together to identify and define the problem with both specialty mentor and a lead mentor. So what exactly are we trying to solve? You're gonna ask yourself that question. And who are we solving it for? So the team will explore possible solutions through brainstorming and research. At this stage, creativity is encouraged and will be challenged. Students are free to explore ideas openly. And from there, the cohort decide together on the direction of the solution and the prototype they want to develop. This demands a great amount of teamwork and communication. Once the direction is established, students begin learning and technical skills needed, while simultaneously you will be building and experimenting with the early model and pre-prototypes. So at YSIS, the learning and the building happens together from the very beginning. And finally, the team will test, will reflect, and refine the ideas before moving into a more developed prototype stage. So, having said that, I would like to invite Dr. Lim to briefly share his experience working with our first cohort project. Dr. Lim, would you like to take it over from here? Dr. Lim?
Yeah, hello? Yeah,
Okay, hi.
yeah.
Yeah, go
I'm
ahead.
sorry, can you say that again, please?
Yeah, would you like
Sorry.
to take it over from here with your teaching experience with the first cohort?
Uh, yeah, related to phase one, right?
Yes.
Yeah. In the phase one, actually we gather together, and as Chloe mentioned before, our students didn't have any background for engineering design process. So actually, we learned how to develop some topics related based on the engineering design process, and then um, we define the problem at first, and then based on the process, we map the possible solutions for each several candidates. And then we decide the prototype and learn and build things that we wanted to develop. And in the first cohort, we learned about some kind of fundamentals of electronics, and also we learned some mechanical engineering basics. And based on those kind of skills, we developed some ideas that our students came up with. Yeah. Mm, so basically, uh, we we focused on the mechanical structure, robotics mechanical structure for our robotic arm, and then we developed those kind of things based on their idea and their curiosity.
Great, great. Thank you,
Chloe,
Dr. Lim.
yeah, do you want me to point out more specific things?
No, I just have some question like what are you most excited to bring to the cohort two?
Oh, yeah, I see. Compared to my previous expectations, actually, our students were very curious
Mm,
and very passionate. And then it was very impressive for me. I have a very long period of the experience for teaching for engineering topics. Um, because they are only in the grade nine, I actually didn't expect too much to expected that much, but they actually focused on the topics very well. And then when I give them some assignments, when I give them some quiz or some questions, actually they really focus on those kind of things to solve it in the class and also after class. So it was very impressive for me.
Great. Thank you. Thank you. Each cohort projects, the dynamic will be different, and actually, I'm looking forward to have a different cohort with a different dynamic to make this very diversified, the group. Thank you so much, Dr. Lim.
Thank you.
So what we're looking for, to join YSIS to become part of the project, you don't need to be the top students in your class. You don't need to already know how to code, build robots, and have all the answers. What matters the most is you're ready to learn, you grow, and then challenge yourself. We're looking for students who are curious, and that's a big part. Students who ask good questions and noticing problems around them and naturally wonder how things could be improved. We value creativity and risk-taking. Within the cohort, we encourage students to think differently. We explore new ideas and step outside of their comfort zone. We're also looking for commitment. So the project will requires consistency, teamwork, and a willingness to show up and contribute even when the work becomes challenging. So, and then the last one is a courage. You gotta be willing to try something unfamiliar, make mistakes, learn from them, and try again. And lastly, we value collaboration, reflection, and care. So students who can work with others, support each other, and genuinely care about this group energy and the goal, that will be make the nice and good learning experience for everyone. So at the end of the day, we're not looking for students who already know everything. So don't take that pressure. We are looking for students who are willing to learn and grow. So this is a quick note to the parents. If we have any parents here, we will challenge your child. We will challenge them to think definitely outside the box and maybe take action to apply to their projects, which sometimes maybe can be frustrating. But that's the process. We would like to support them and we would like to support the growth. Okay, so how to apply? So there will be application form. There is actually already an application form online. After today's session, I will send everyone an email with the application form attached to it. The application deadline is May 31st. And after we pass the deadline, then we will start interviewing the students, which is a interview invitation. You will receive interview invitation and then moving towards the onboarding process. So those are the timeline, May 31st, application deadline, application close. Early June will be interview and the following confirmation will happen, also happening at the second week of June. So here, before we go into moving to Q&A, I have some question already shared when you register to today's info session, and this is the things we would like to first talk about. So I have some question, how much does it cost, and then where the session held. So currently the cost is $600 per person per month, which covers 3 hours meeting learning session per week. And also one touch base if that's needed. Material will be outside of this cost. It really varies from project to project. And the 100 to 500, that's just the estimate. And then most likely 100 to 50, 100 to 500, that will be through the whole project. It won't be just monthly. Competition fee also, that's something outside of the $600. So $600 covers in-person 3 hours, weekend meeting session, also the midweek checking in or any kind of support the students need at any time with their project from the mentor. The time commitment, so be 3 hours per week, plus a midweek virtual checking in could be 30 minutes to 60 minutes. So students are expected to work 3 to 4 hours per week in total, with more during the key building phases. Each phase be 2 to 4 months, a minimum 3 months, so minimum 1 phase commitment. Completion of all 3 phases is roughly about a year. So here's a quote before we go. I would like to share. The first, I really like this quote. The first step is to establish that something is impossible, then probability will occur. This is some kind of things I want a student to keep in mind. Don't just because you haven't seen it yet and that's not possible. If something's sparking you, do take action. So thank you so much for listening to this info session and joining the info session. To all the students in the room, really, no matter whether you decided to join at the end or not to joining in, this is something I want you to keep in your mind. When something sparks in your curiosity or passion, don't silence it. Don't forget about it. Explore it, questioning it, pursue it with courage. That's how you can live your life to the fullest. So yeah, I'm gonna stop sharing my screen and I'm gonna start a Q&A session and see if anyone have any question. Question, anyone? No? Okay, if there's no question, that would be end of the info session today. I will putting on this email here. If you have any question, feel free to email us and we will be able to answer your question. Other than that, and that will be end of the info session. Thank you so much for spending an hour with me. Thank you very much.
Thank you, everyone.
Thank you.
Okay, Dr. Lim, have any question?
Yeah, no question.
No question.
Yeah,
Okay, thank you so much.
yeah. Thank you very much.
Yeah, okay, have a good week.
Yeah,
Thank
have a
you,
good
thank you.
Yeah, good week. Bye.
Bye.
Bye.